A very good morning to you all. On behalf of IIT Bombay and Interdisciplinary Program in Climate Studies, it gives me immense pleasure to welcome all our dignitaries and delegates across the country and overseas. Please switch on the silent mode in your mobile phone so that we can carry on with our program without any disturbances. And thank you. Today we are here for the International Climate Research Conclave, organized by Ministry of Earth Science and Department of Science and Technology, Government of India. And hosted by Interdisciplinary Program in Climate Studies, IIT Bombay. As we know that India is a part of the solution and is doing more than its fair share to address climate change. Before we start today, I would like to quote our Honorable Prime Minister, Sri Narendra Modi, who has quoted that an idea becomes a mass movement when it comes from discussion table to dinner table. And he also called people's participation and collective efforts for addressing climate change. With this spirit, this conclave will bring all of our researchers to discuss India's recent climate areas and progress and agenda for future growth, a vision for 2030 and beyond. Today we are very fortunate to have with us our guest of honor, Honorable Secretary Dr. M. Ravichandran, Ministry of Earth Science, our chief guest, Honorable Secretary Dr. Srivari Chandrasekhar, Department of Science and Technology, Honorable Secretary Dr. Akhilesh Gupta, Science and Engineering Research Board and Senior Advisor to DST. So now, I would request Professor Subhashish Chaudhary, Director IIT Bombay, and Professor Subhimal Ghosh, Convener, IDPCS in Climate Studies, to lead all our dignitaries to the dais. Now, I may request Professor Chaudhary to honor our guest of honor, Honorable Secretary Dr. M. Ravichandran, Ministry of Earth Science. I would request Professor Chaudhary to honor our chief guest, Honorable Secretary Dr. Srivari Chandrasekhar, Department of Science and Technology. Now, I may request Professor Chaudhary to honor our chief guest, Honorable Secretary Dr. Srivari Chandrasekhar, Department of Science and Technology, Government of India. Thank you, Professor Chaudhary. Now, I would request Professor Subhimal Ghosh to honor Honorable Secretary Dr. Akhilesh Gupta, Science and Engineering Research Board and Senior Advisor to DST. I request Professor Ghosh to honor Professor Subhashish Chaudhary, Director of IIT Bombay. Thank you, Professor Ghosh. Now, I would request Professor Subhashish Chaudhary to deliver the welcome address to our dignitaries and participants.
Professor Chandrasekhar, Dr. Ravichandran, Dr. Gupta, Professor Vimal Ghosh, my colleagues here, distinguished delegates, and students. We have this special program today, which is probably very timely and relevant in terms of what's happening all around. Okay. We are very delighted that we have a patronage of the Ministry of Environment or Art Sciences, along with their dignitaries all being presented here in terms of seeing that how academia, along with the government, organizations, and other industry can work together on one of the most important thing that is actually in very much touching our lives. Okay. As we talk, even this morning I was reading the newspaper that the heat wave that has happened, it even killed 2 of the little cheetah cubs, okay, which is like the temperature showing to 47 degrees. Okay. So this is a distress call in a way to the every, I think, not only the human being, but even to every creature on the Earth's surface, that there is a need to do something. And we are happy to say that IIT Bombay has been working, now it's about 10 years of our special program that has been created on the climate studies. And this is something as a continuation in the environment science or department is another one, which work very closely with them. And this is where I think we need to join hands with all the organizations, all the research organizations, and actually those who are doing. And this is a time that, for the next 2 days, we have this special program where I hope that you will talk to each other, set up a strong bonding, not in terms of just personal relationship, but in terms of how we can work together to alleviate the problems that's actually all surrounding us today. On behalf of IIT Bombay and on my own personal behalf, I'm very happy to welcome you all to the campus. It's hot and humid, very much as you can see today, but I'm sure that even without that, maybe by evening you may be able to take a stroll or maybe early morning. Okay. So enjoy the campus, whatever the life that the campus offers, and I hope the 2 days of deliberations will be very helpful in the designing what lies ahead for all of us. Thank you so much, and I hope you all enjoy it.
Thank you, Professor Chaudhary. Now I would request our Honorable Secretary, Dr. Akhilesh Gupta, to share a few words about the overview of ICRC 2023.
Respected Secretary DST Dr. S. Chandrasekhar, Dr. Ravichandran, Secretary of Sciences, Director IIT, Dr. Vimal Ghosh, all the distinguished participants of this conclave. Very good morning to everybody. This is in fact a historic day. Exactly 1 year back, on 2nd May, in this very hall, we in fact celebrated 10 years of this center, interdisciplinary center at IIT Bombay. This IIT Bombay was the first center of excellence of DST, set up in 2012, and thereafter, in fact, the DST Center the climate change program had spread through the entire country, and now we have 12 centers of excellence and 20 major R&D programs and so many other things. Actually, the kind of journey that weather and climate research had in India is very interesting. I mean, if you go back 45 years back, the only IITM and in fact IITM was created around that time, but IND was the main institution in the country working on weather and climate, and of course some of the academic, like for example BHU and IIT Kanpur, they were one center, and also in Kochi University of Science and then one of the oldest was Andhra University. For only few others, so you can count on finger at that time that how many institutions are working in weather and climate. But today, the kind of expansion that has taken place in weather and climate is very, very unprecedented. We have something like 1,400, in fact, institutions going right up to the college level where the weather and climate are either taught or do research. Maybe the number is less, but so far as teaching is concerned, it is a good number. And more than 3,500 scientists and students, they work in the area. So this expansion has largely taken in the academic institution, and to our surprise, so much of expansion has taken into the private institutions, private universities and all. That clearly shows that there is a need for expanding our climate research to serve the aspirations and the demands of our researcher. One of the things that DST has contributed in the last 1 decade or so is building that capacity, both institutional and human. Today we have something like 700 research students in the country working in different programs for DST. That itself is a very, and in fact, I must say that, IIT Bombay was the one which has maximum number of research students among all the centers. Of course, now BHU also has good number of students. Even IIT Delhi has good number of students. Put together, this has been a very kind of change that we have seen. I will not take much time, but only say that the idea of today's conclave was also, in fact, conceived just 1 year back. On the very second May, Dr. Ravichandran and myself, we were here, and we thought of that DST and OES put together can set up this kind of joint consortium and can work together to create a national climate research agenda. So today we are here. In fact, we are so thankful to Secretary DST that he could present here, and this is the place, this is the time that we are going to unveil our national climate research agenda, which is going to take forward. So I'm so thankful, and the team led by Suvimal to organize this conclave has done a tremendous job. I know last few months they have been working almost every day. This was a kind of challenge that they had, and they managed so well. So I compliment Vimal and his team for doing an excellent job for organizing this, and all of you for participating. In fact, the authors who led the writing of the chapters for this report, and they also work, in fact, timeline that we have set was very tight, but creating a document in about 6 months' time itself is a very kind of praiseworthy. Thank you very much, and I must say that we are so delighted that this conclave is taking place today. Thank you very much.
Thank you, Dr. Gupta. Now I would like to invite our guest of honor, Honorable Secretary, Dr. M. Ravichandran, to address our audience.
Dr. Chandrasekhar, Dr. Chaudhary, Dr. Aglesh Gupta, Suvimal Ghosh, and various invitees, delegates, friends and colleagues. Very good morning to all of you. Of course, it is a great pleasure to be here as part of this conclave in terms of discussing and various ways of what are the things are happening in climate change, what is the way forward. For that, you all assemble, and I am very thankful to IIT Bombay for organizing this such conclave, and I thank you for Subimal Ghosh and his team for organizing this one. Of course, when you talk about a climate change, we know that in all spheres, especially in the climate change, either it is a solid state of glaciers or sea ice or maybe the ice shelf, all are melting, and the liquid state also warming in the ocean, and the atmosphere also warming much faster. Of course, when you're talking about climate change, most of the things we talk about, of course, climate memory is mainly from the ocean, but at the same time, we never know what is happening in the polar regions. The polar region is one region where you get all the things are amplified. Maybe the atmosphere is warming 4 times faster than the global mean in the other places, and the sea level changes is contributed by the glacier melt and other things, and also a lot of sea ice reduction in the poles. It is complicating various atmosphere and ocean interactions. I think we need to have more and more effort to understand the system, what is happening in the polar regions, because in the Arctic itself, it is changing. Maybe whatever the changes are happening in the Arctic, it is a profound influence, not only from the local in the Arctic regions, but also in the other places like in the tropics and the our regions also. In the Arctic itself, I think last year we have made an Arctic policy. What is that India's Arctic policy? The main focus is the sea ice depleting, and we have 4 consequences because of the Arctic, maybe in terms of science as well as geopolitics as well as various other things. Of course, we are more concerned about the climate change. So what is happening in the Arctic, and we are influenced in our regions, and what is happening in our region is also influenced in the Arctic regions. You know, most of the teleconnections are what is happening. Of course, there are other political reasons, because political means both the living as well as non-living resources. It is abundant in the Arctic Sea. So because of sea ice melting, so everybody want to pie on that. So for that, what is the strategy is required is another thing. Of course, lastly, this shipping route will be changing dramatically. So because of shipping route in changing, so there will be an economic corridor shift. So economic, geopolitics, as well as climate change, all these things are very important in terms of when you talk about the Arctic. Then coming back to even Antarctic too, whatever convection is happening in the tropics, always it is transported to polar regions, especially in Antarctic. Roughly about 20% of convective activity is happening in maybe in the tropical region. It is transported to Antarctic as well as Arctic, so that the melting is happening much faster. Of course, this is a year, as of now, the Arctic sea ice is the global, actually it is the world record now. It is the lowest in the sea ice now, as of now. So what is the influence of Antarctic as well as Arctic? We need to study and understand, because the polar region is the first place to cry are to sense the climate change. So that's why it is a cryospheric effect. So I think we need to put more and more effort in understanding the cryosphere, not only in the Arctic and Antarctic, but also the water tower or the third pole of Himalaya. It is also depleting. So when it is going on depleting, so what will be the water resources available around the country? Because as of now, it is about 2 billion people are dependent on the water tower of Himalaya. So what will be the consequences of this climate change? We need to understand. So what I mean to say, all three poles, we need to understand better. But you all know that the climate projections very bad in terms of polar regions. So I think we need to more have observations. Then we should have more understanding so that we can put in the model, we can have a better predictions and better projections for the policy making, decision making, or science-based decision making. As we talk about, I think maybe the 2020, maybe 21 to 30, it is a decade of the ocean. Maybe we need to understand various processes, what is happening in the ocean. But I am sure in the future, maybe in 2040s, the polar regions may be a dominant role, not only for the policy as well as geopolitics and other phenomena because of the various reasons of Arctic sea ice. Maybe no more sea ice will be in the summer in the Arctic, so there will be a big problems. And Antarctic also treaty is going to be end in 2040s. So what will happen in future Antarctica? Whether it will be a natural laboratory or everybody will look for the pie in the Antarctica, we don't know. And also water tower in Himalaya also is depleting, so that what will be the treaty about Indus treaty and other thing also, it will be we need to worry about. So that time 2040 to 50, it will be a major polar complexities will be there. So we need to equip in terms of both science understanding as well as policy making. So it is imperative we need to derive from the science-based solution for policy makers as well as economic impacts. Because I think last 1 week, many of the economic advisors in India, they were worried about the financing, about the things. The main ingredient is for that climate change. So I think what we know is not much we are not able to understand. So I think we need to understand much more, and we need to bring out the more and more policy decisions in terms of what is happening in the in our waters or our regions, either extreme rainfall or maybe the heat wave or even marine heat wave. All this complexity we have to quantify, and we have to tell with less uncertainties so that policymakers can make a proper decision in the coming years or decade. I think this conclave will bring out various discussions and other things, and I am sure that you will bring out various recommendations which will be easily implementable recommendations, so that we can take it forward for the country benefit as a whole as well as for the global common. Thank you very much, and thank you very much for inviting me for this conclave. Thank you.
Thank you, Dr. Ravichandran. Now, I would like to invite our chief guest, Honorable Secretary, Dr. Srivari Chandrasekhar, to address our audience.
Is this your watch? Okay. Friends, good morning, and thank you, Subhashish, for hosting us today here to debate on the climate changes what we are encountering. And Ravi has elaborated on what is that we all have to be doing. I have not made any talking points to share with you because I'm not a climate scientist. I belong to a community which is called chemistry polluting community. So we only keep polluting this planet with chemicals, but for the well-being of all of you. And if chemistry is not there, I'm sure none of us are sitting in this audience. You don't have your chair, which is a chemical, or the mic material, the plastic, everything is a chemical. While we are talking of climate change or the climate impacts on all of us, I only go back and look at the history of what is that the so-called Homo sapiens sapien has done to this planet. I think if Homo sapien was not there, climate would have been as normal as it would have been. Because no animal kingdom on this planet ever has attempted to snatch away others' meal or others' properties. It is the character of the only Homo sapien. So because Homo sapien has made this problem for this planet, it is the responsibility of all of us as the lineage of Homo sapiens. It's our job to again do the course corrections. When I talk to friends who are experts in this area, they always say that damage is already done and we're already late in reacting to the climate changes. I don't know how late we are, whether it's reversible. Only during the COVID pandemic, we all realized that certainly it is a reversible process. The moment we have shut down all our factories and lockdowns were put up, there were many news articles which say that from Delhi you could see Himalayas. That means the air has become clear, everything is good, all is well. So this is an indication that one pandemic has at least gave us a hope, while pandemic really killed all of us, but gave us a hope that climate change is certainly a reversible process, and if we behave well, there is a good possibility that we can pass on this planet to our next generations with proper conditioned planet. I was looking at some of the historical aspects of the climate change, and it only occurred to me that in 1912, in one of the British newspapers, it appeared that the global industrialization, which has begun early 19th century and late 19th century, that was the time we started burning coal, and that may be the beginning of the challenges what we are encountering today. And now we are all getting committed to see how we will reduce the fossil fuel burning so that we will give some rest to this climate to restore its original character. As Ravi was mentioning, while the melting of Arctic, Antarctic, Himalayan belt, they all have direct impact on the water bodies, and certainly ocean, which occupies 70% of our planet, will have a much larger role, and how we protect the ocean would certainly be larger importance to all of us. Few months ago, 2 months actually, not two, several months, I was with Dr. Dimri in his institute in the Indian Institute of Geomagnetism, and he was doing a workshop with some of the young PhD scholars. And I don't remember, one of the speakers there was referring to a slide which was made when Ford first introduced a motor car. And I think the claim made by this company was that we are changing the way we transport materials and all of us, from classical bullock carts and horse carts to an engine which runs on fossil fuel, which only gives you a small smoke from behind, but goes at a much faster pace than your horse or camel or any other transport mechanism. And the pollution these animals are causing on the road, because they keep dung on the road because they eat grass, and while they are going from one place to other place, they keep spoiling the road in the form of dung. He said dung was the biggest pollutant, and now we are coming with a little smoke from behind and whole world will be green. But now we look back and see that was again a beginning of another damage. And now we look at bullock cart, maybe more circularly economized transportation, because it eats grass, which is biodegradable, and it gives you dung, which is also biodegradable, and it has lesser impact on the planet. So it's a responsibility for all of us. Climate change is not the responsibility of climate scientists. Climate changes are happening because of other peripheral activities which are happening around the climate scientists. Climate scientists have to keep a watch on which are the areas which are creating larger impact on the climate. Of course, natural changes which have happened over millions of years, I don't think we have any control. Certainly, a sudden spurge of global warming has resulted from ice era to temperatures where we are all livable. If we were to be in the ice age, I'm sure Homo sapien would have been not there. So certainly there was an accidental melting of ice and increase of temperatures which allowed all of us to be on this planet. I do believe that many researchers who are advocating climate changes are happening because of greenhouse gases. Is greenhouse gas the only responsible gas for the global changes, or are there any other things which are contributing to this challenge? Certainly deforestation is one important activity which human beings do, and that's creating a lot of pressure on the climate impacts. Similarly, abuse of natural resources, that's where Honorable Prime Minister has given a clarion call on lifestyle for environment. And all of us have to begin someday what is that little lifestyle change which will have a little positive impact on all of us. When you go for a conference, our conference begins with plastic and ends with plastic. Starting from the badge we wear, to the water bottle we drink, to the plate in which we eat our meal, and from the day we begin our carries in the morning. So everything is putting a lot of pressure on the climate, and it's the responsibility of all the citizens of this planet to make sure that we pass on this planet to our next generations with utmost care and without any further warming of this planet. While we are aware that fossil fuels contribute to major contributions of global warming, we also look at the lifestyle. If it is better, certainly we can reduce burden on healthcare. If we have good lifestyle, burden on the medical production of products will decrease, and that would have a direct impact on the climate. Also, agriculture industry, which again contributes enormously to greenhouse gases, we need to bring in good practices in agriculture so that we will minimize whatever impacts agriculture can do on this planet. Similarly, when I talk to my friends in chemistry community, the biggest mistake all our chemistry friends do is whatever is available in this nature's earth crust is always in a safe form. Coal per se has never given any damage to the planet. It's the wood which has buried over a period of time has become coal, and coal has no direct impact on global warming till we burn it. So what we do is we are going to change the oxidation state of carbon. Just by burning it, you make carbon dioxide. And similarly, sulfur, we make sulfur dioxide. Similarly, nitrogen, we make nitric oxide. And these higher oxidation state materials, what we use, they are giving larger challenges. So responsibility of scientists also on how we can really capture this carbon dioxide which is getting emitted from various industries and put into recycled form, which goes back to carbon, and again carbon dioxide and back to carbon. DST has been trying to advocate how we can really do carbon capture and utilization. We have several calls on utilization of carbon capture. I do believe that climate scientists who are assembled here also would alert fellow researchers on what changes are happening and what are the major sectors which are causing impacts on the carbon footprint on this planet. Construction industry is another major sector which causes a lot of damage to the planet. How we can bring in eco-friendly construction. Again, I think it's an important responsibility of scientists who are working in the construction industry. I do believe that all of us will come to some consensus as this event goes on. And these meetings are not restricted to just climate scientists, but you embrace other researchers who are also making materials for the comfort of the mankind to see that which are the materials which cause larger impact on this planet. Also, when we look at our research investment from DST, I only would like to share with all of you that DST is driven by the ideas given by our expert members. I'm sure IIT Bombay has been playing an important role in what programs DST have to operate. I request Subhashish that he will interact with his faculty and come up with areas into which DST has to invest its research funds, that we really get return on investments with utmost care and we protect this environment properly. I wish this conference all the best, and I do believe that by end of this 2-day workshop, you will come out with some concrete white paper which will have a larger impact on all of us. Thank you. Jai Hind.
Thank you, Dr. Chandrasekhar. Now, I would request our guest of honors, along with Professor Subhashish Chaudhary and Professor Shubhimal Ghosh, to release the book on India's Climate Research Agenda 2030 and beyond. Thank you. Now I request Professor Shubhimal Ghosh, convener IDP in Climate Studies, to formally present the vote of thanks.
Dr. Srivari Chandrasekhar, Dr. M. Ravichandran, Dr. Akhilesh Gupta, Professor Subhashish Chaudhary, eminent climate scientists around the globe, colleagues, students, and distinguished guests. Before starting the formal vote of thanks, we'd like to announce something related to interdisciplinary program of climate studies, which was of course India's first PhD program on climate change, focusing on all 3 areas of climate science, climate adaptation, and climate mitigation. And that has completed the glorious 11 years, contributing significantly to all the 3 areas of climate. Translating this scientific knowledge into societally relevant service needs climate entrepreneurship, which is still at a nascent stage in this country. We are very happy to announce that our alumni has stepped forward to promote climate entrepreneurship. With the support of our alumnus, Dr. Vinaya Kapoor and Dr. Samir Kapoor, this year onwards we are starting an award which is known as Accelerating Climate Energy and Sustainability Solutions Award. This is for the students on transforming climate adaptation and climate mitigation ideas into solutions. We are expecting a huge participation from the students towards technology development for climate resilience. Our sincere thanks to Dr. Vinaya Kapoor and Dr. Samir Kapoor, and also Dean Asia, Professor Goody, for facilitating this. Now coming to the climate conclave. On behalf of the organizing committee, I stand before you today to express our heartfelt gratitude and extend warm vote of thanks for your presence in this first of its kind climate research conclave to frame India's climate research agenda 2030 and beyond. This gathering has brought together researchers and experts in climate science and adaptation around the world, all united by a shared commitment to address the urgent global, regional, and national level climate change. First and foremost, we extend our deepest appreciation to Dr. Srivari Chandrasekhar, to Dr. M. Ravichandran, who generously shared their knowledge, experience, and insights with us. Sir, your speech has shed light to the complex issues surrounding climate change, inspiring us to think critically and act decisively to create sustainable future. We'd like to extend our sincere thanks to Dr. Akhilesh Gupta for conceiving the idea of preparing India's climate research agenda and getting it discussed by the climate scientists all around the country in this conclave. This is also a great opportunity for young climate scientists and students to interact with the experts and peers and possible collaborators to contribute significantly to this multidisciplinary area. During the preparation of conclave, he was always been available for discussing on climate research agenda and ICRC despite his extremely busy schedule. We are ever grateful to you, sir. We would like to express our gratitude to Professor Subhashish Chaudhary, Director IIT Bombay, for his participation and encouraging words in this inauguration of climate conclave. Under his leadership, our institute considers sustainability as one of the strong research focus areas. His wholehearted support to the IDP climate studies and related activities are really commendable. We are also thankful to Deputy Director, Deans, heads of different academic units, and colleagues from IIT Bombay for their support to the growth of climate studies. We'd like to extend our thanks to our sponsors, Ministry of Art Science, ACRB and DST, who have played a pivotal role in making the conclave possible. A special note of appreciation goes to Dr. Anita Gupta, Dr. Nisha Mendiratta, and Dr. Sushila Negi, Dr. Jagvir Singh, and Dr. Gopal Iyengar for their active engagement and guidance for the arrangement of ICRC. Special thanks go to Dr. Sushila Negi for always being available to our queries and for continuously being in touch for the planning of ICRC and providing useful guidance. I am grateful to the authors and reviewers of the draft India's Climate Research Agenda 2030 and beyond, which will provide guidelines to the climate research community of the country. A special note of appreciation goes to all the participants who have traveled from far and wide to be a part of this conclave. In this conclave, we have a total participation of around 200 delegates across different parts of India and around the world. Your active engagement and passionate contribution will enrich our discussion in the next 2 days and will elevate the level of discourse. We'd like to express our gratitude to the organizing committee members and volunteers who have worked tirelessly behind the scene to ensure the smooth running of the conclave. I am thankful to our organizing committee member, Professor Shubhankar Karmakar, Professor Kartikeyan Lanka, Professor Vishal Dikshit, Professor S. Ravichandran, Professor Anshuman Modak for their continuous support. The entire event was managed by the exceptional team of staffs of climate studies, Archishmita, Shiva, Harsha, Kalani, Balika, and a team of 40 plus students and postdocs, led by Priyam, Siddhesh, Tavin, Tejasvi. I am requesting them to please stand and please give them a big round of applause. Lastly, but certainly not the least, we extend our heartfelt thanks to the venue staff, technical team, and all the individuals who have contributed to the logistic arrangements. Thank you, and may we all be inspired to contribute to the science and technology for a climate resilient India. Thank you very much.
Thank you, Professor Ghosh. Now we all may raise for the national anthem. Thank you, everyone. You may be please seated. So before we break for a tea, I would like to request that post the tea, we will assemble here at 11:15 a.m. and we will be having our next keynote session, which will be addressed by Honorable Secretary Dr. Akhilesh Gupta. And also we have a student poster displayed outside the ground floor of VMCC. So along with tea and some interactions, you can enjoy our activities which are going on inside the department in climate research. And the high tea is been arranged in the outdoor cafeteria of VMCC, ground floor. Attention everyone, I would request all our dignitaries and delegates to kindly be seated once again, as we will be having a group photographs along with our dignitaries and delegates. All right, so we will have our group photographs after the keynote session. Thank you.
हॅलो 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 येते आवाज हेलो मैम क्या कर रहे हो
Check. Check, check. Check. Check, check. Check, 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 check. थोड़ा और बढ़ाने की.
To you all, on behalf of IIT Bombay and Interdisciplinary Program in Climate Studies, it gives me immense pleasure to welcome all our dignitaries and delegates across the country and overseas. Please switch on the silent mode in your mobile phone so that we can carry on with our program without any disturbances, and thank you. Today we are here for the International Climate Research Conclave organized by Ministry of Earth Science and Department of Science and Technology, Government of India. And hosted by Interdisciplinary Program in Climate Studies, IIT Bombay. As we know that India is a part of solution and is doing more than its fair share to address climate change. Before we start today, I would like to quote our Honorable Prime Minister, Sri Narendra Modi ji, who has quoted that an idea becomes a mass movement when it comes from discussion table to dinner table. And he also called people's participation and collective efforts for addressing climate change. With this spirit, this
check, check, check. Check, check. Check, 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 check.
Hello, mic check. Hello, hello, mic check. Hello, mic check. No, I can just okay.
I would request our dignitaries and delegates to kindly be seated as we will start our program shortly.
I think it's working. Hello. Yeah, ठीक है, that's fine.
I request our dignitaries and delegates to kindly be seated as we will start our next session shortly. I will announce. No. Once again, welcome you all for the keynote talk. The session will be chaired by Honorable Secretary Dr. Srivari Chandrasekhar. Thank you.
I will do it from here. So, Mr. Chairman, Dr. M. Ravichandran, all the distinguished participants here, this is not an usual conference that we have. In the past, we used to have like talknet series where large number of participants as IMS members and others they participate. This conclave is for a purpose, and as I said, the idea was conceived a year back when we interact. It was a breakfast meeting that Dr. Ravichandran and myself we had, and then we decided, and he was kind enough, to welcome this idea, and he said this is the great idea that we first set up a consortium between the Ministry of Sciences and DST, and then launch this kind of program. So, my interact presentation will also cover why this consortium and why this agenda, and what is the way forward for this agenda, and is it just a And usually a conference where you have 2-day conference, you at the end of the conference you bring out some recommendations, and those recommendations will never go anywhere. They will just be for the purpose of academic record. So, here I am not going to cover, you see the report is very comprehensive. There are 30 authors and several reviewers, and fortunately both reviewers and authors, many of them are here. So, I am not going to go into much detail about the report outcome, that is also always available, but I will give glimpses of that, features of the thing, and then I will come to what is the idea behind the whole thing. Is that working? Oh, sorry, I had to switch it on. Can you see? It's not working. It's now coming. So, you know, the climate research in the country, in fact, right from the first IPCC assessment report, which came in 1990 to now. So, it's nearly, you can say 30 years, 3 decades that, you know, climate research in India has started, and in most of these response to most of these reports that from IPCC, we had several initiatives, mostly led by initially IND and IITM and NCR. Later on, other institutions also participated into this thing. But you know, so in every IPCC report, there has been emphasis on the need for climate research and the emphasis on the impending impact of climate change in times to come. Till the third report, you know, the language was very softer. There were not enough evidences also, and so it is always said that extreme events are going to increase, your temperatures are going to increase. But then this was the time when the fourth report came, that India had responded in a big way. And I have been very fortunate to have been part of the NAPCC formulation when the Prime Minister had called the meeting and he wanted that we must create a national action plan on climate change. We drafted this and 8 missions were launched. Along with that, so this is what I wanted to mention here, that you know, not just extramural part like mission related issues, even the Center for Climate Research in IITM was set up. Of course, the talk for setting up the center started way back in 2002, but it was set up in 2010, and along with the, almost concurrent with that, we started setting up the Center of Excellence as part of DST. And as I said, IIT Bombay was the first center. Then we had ISC Bangalore and then IIT Madras and these are the 4 centers which came in the first lot. Thereafter, when the 5th report came, more centers came in, and so on. So now we have a huge network of institutional mechanism, both as part of the Ministry of Earth Sciences and part of the supports on the Government of Science and Technology. So DST, as I said, these are 8 national missions, and 2 missions are being given to DST, National Mission for Sustaining the Himalayan Ecosystem and the National Mission of Strategic Knowledge for Climate. Both missions were focusing on building the human and institutional capacity, and we have these many, this is the status that these many centers have been supported by us in different parts of the country, and several new initiatives, and I am not going to detail because this is not the topic of discussion today, and this is a center of excellence name, Greater R&D Qurans. You can see they spread all over the country. And also network program. There were 9 network programs that we spread all the over country. More than 120 networks, number of credits were there. Something like 700 scientists were associated with the network and all. And one thing that DST has really done, and I must say that this is one initiative where it has made difference at the state level. Normally state level climate change not very active, and so we set up 30 centers all over the country. Almost every state now has one center on climate change. They are doing work on capacity building as well as awareness, and some does the research part. And this is the overall. So, look at the kind of spread that we have 170 credits, 350 institutions are part of it, and nearly 1,700 scientists are working as part of this thing. And good part is that nearly 600 to 700 students are, research students are working as part of this thing. Now, this is the, let me present that this is the ecosystem that exists in the country on climate research funding. So, if you have the 3 part of climate science, adaptation and mitigation, on science it is MOES and DST. One is intramural, other one is extramural, largely extramural and largely intramural. And adaptation, in fact, MOES also works, DST also works, and then many others, CSIR, ICR, ICMR, Jal Shakti. Many of these agencies are working in adaptation. In mitigation also, MNRE, DST also works, CSIR works, Ministry of Power, Urban Development and Environment. So, this is the ecosystem that exists. Today, in fact, the discussion reference to this national research agenda focusing on science and adaptation largely. Mitigation, there is the other ministries they are taking care. Since here the context is that the initiative between Ministry of Earth Sciences and DST, the area of science, largely science but partly adaptation also. See, these are some numbers I just wanted to give. DST and MOES put together fund nearly 90% of climate science research in the country and nearly 50% of adaptation research in the country. And if you put DST and MOES put together, 70% of science and adaptation research are funded by both these institutions. 95% of MOES funding is intramural, 90% of DST funding is extramural. Of course, 80% of mitigation research is being funded by MNRE and Ministry of Power, and 7% by DST and rest by others. So, this is just statistics that this is if you see the funding by MOES and DST. So, largely intramural MOES, largely extramural, mainly 4 institutions, I mean there are others also, but IMD, IITM and Central Lab inquires. With 350 institutions across the country supported by us, 400 scientists work with the MOES research, and I am not talking total scientists, whereas the DST nearly 2,000 scientists and 700 students, this is the number that we have. Annual budget is of MOES on research is 350 crore. DST, it is DST plus SCRG put together 150 crore. And here the difference is that research in MOES is predominantly institution driven, and whereas the DST is largely individual driven, but in some center excellence and all, it is institution driven also. MOES has very strong R&D infrastructure. In fact, one of the best computing resources is available in Ministry of Sciences. In fact, the other day news was that they are going to have another big supercomputer, several petaflop computer worth 900 crore. That is the best available in the country, and extramural system cannot match that. We have good infrastructure, but only at the center of excellence or the task force. So, while MOES climate research has depth in terms of its support for the infrastructure, DST system has width. It is that's penetrated into several institutions, and that is a need was felt to combine the strength of two requirements to set up a national climate consortium, because then you can have the one institution strength leveraged by the other institution strength. This is the idea why we need a consortium of this kind. So, last year when we were here, we in fact thought of, and later on we announced this National Climate Research Consortium. And as part of this consortium, the first thing that we did, and this is again a new idea that we thought of bringing out, that it is I don't know, some of you may be knowing, the NSF does this way. When NSF decides to work on a particular theme, they did recently for quantum technologies, and they decide to do work in some area, and they create a national agenda for that, national research agenda for that. And the idea is that once you create that national research agenda by involving all the best experts in that area, once that is ready, then that can be then taken up further for grant. So, agenda preparation is not just a report. The idea is to take that forward for the grant, and so that instead of inviting proposals from individual TI, let's do it little top down and ask the experts who prepare this thing, and this is why the kind of pattern that format that we followed, and thanks to Vimal for doing that, first create the identify people, and in fact deliberately and very honest, deliberately we try to identify younger people, say in the 50s and or not very late 50s or early 50s and even earlier than, and then take them, because if you are preparing agenda for 2030, I think and beyond, I think we need younger people, because you need to have those people existing beyond 2030. So, if you have two very old people, then that may not be. So, the idea was catch young people, ask them to prepare this agenda, and then they will be identified in future for providing research grant. How it will be done? That strategy is still being worked out, but I am just saying that this is the idea behind the scenes. This was the drafting committee that was set up, and so you had nearly 25 people as part of this drafting committee, and then the report was prepared, and these are 30 authors, co-authors of this report, which is released today. Now, it contains some very, and again I would very honest that not that this climate research agenda include everything in the climate science area and adaptation area. We had identified some priority areas, and so can you go to next slide, please? It's not moving. Now, the motivation for this report came from the 6th IPCC report. There are two important messages that come from the 6th report. The first message is that we are going to have abnormally high temperature, and average temperature might exceed 1.5 degrees centigrade in next 2 decades. That will create, the kind of big impact. And if you look at this figure, I think it's not very clear, but I can just read it out for you, that even a temperature rise of say 1 degree temperature has increased the heat wave by 3 times, and if you see if temperature rises to 2 degrees centigrade, the number of heat wave will go to about 5 to 6 times of today's level. That is a big worry, because it's not just average temperature that is going to increase, but it is the frequency and intensity and duration of heat wave that's going to increase, and not just 1 or 2 times, but several times. And that is a worry, because that will impact the society in a much way. Similarly, so this is a 10-year event, that if you count 10-year event, so if it is taking once in 10 years, it is going to be 6 times in 10 years. So that kind of frequency is going to increase. Similarly, if you study 10-year heavy rainfall, heavy precipitation, this is going to be increasing several times, nearly 2 times of today's level, if it is temperature rises to 2 degrees centigrade. So both heavy heat wave and heavy rainfall, these are the 2 basic parameters that are going to change the entire scenario. And that is the worry at the end. All that are interconnected. Higher temperature means higher rainfall potential and higher rainfall intensity. All that are connected. So what we did, we identified and these areas which are going to be the priority area for research in next 5 to 8 years. And that is the first and the most important is the climate modeling. So I'm going to elaborate on that, but just this is a very important area, and in fact Earth Sciences is doing in a much bigger way at IITM, but we also started in DST as part of the several centers of excellence. Monsoon continues to be a big challenge, not just the prediction, but also the variability. The monsoon, the kind of variability that we are witnessing in terms of the both intra-seasonal and inter-annual and interdecadal, all kind of variability that we are talking about. Monsoon continues to be, and in fact simulation of monsoon itself is a big challenge, and models are in fact struggling to produce these kind of extreme events, as I mentioned, going to be the biggest challenge, because this is the turning point for the entire thing. Extreme events are going to put a lot of challenges on the weather forecasting. And yesterday the event in Delhi, our secretary's flight also got delayed several hours. All that will happen, because that associated issues, turbulence and all, going to be very important. And so extreme events, both again in terms of its number, its intensity and duration, all are going to be. Aerosols are going to be, we continue to have issues, that urban pollution, that issues are there. It's not just a pollution issue, it has so much of associated issues, impact on rainfall, impact on monsoon, impact on health, and impact on agriculture, and so many. So aerosols are going to play an important role. Urban climate is a big challenge. In fact, now every city is witnessing heavy rainfall, and the magnitude of urban climate is several times more than the global climate. Temperatures, heat islands have been noticed, have been observed in many cities with the value of 8 to 10 degrees centigrade also. So that is a different science, different from global science, and therefore separate treatment or this thing is required. As in the morning, Dr. Ravichandran also mentioned the glaciology. In fact, although a lot of work has been done, but this is required a coordinated program. We already did, in fact, about a decade or so back, we in fact had to face that embarrassment of mentioning of some of the glaciers in India are going to be receded by 2023. Those kind of, we have come a long way, but now still we can say there is so much of requirement for glaciology research in a coordinated way. Although institutions are doing separately, academic institutions are also working individually. I think we need a coordinated. We tried a coordinated effort. I think we need much more. Professor Kulkarni is here, so we will bring glaciology into focus in the research in interinstitutional coordination levels. Entire Himalaya is getting better, and the temperature, rainfall is already impacting. In fact, the magnitude of change that is taking place in Himalaya is at least twice the change that is taking place in the plain area. And so Himalaya being our very importance on our livelihood point of view is very important. And along with that, of course, the coastal, but coastal will come in under the other category also, but Himalaya needs to be treated separately. Now, as I said, modeling is the key issue, and there are challenges of modeling. As I said, institutions are working quite creatively. Ministry of Sciences, in fact, working on models like ESM model, and there are global models run by NCM developed kindly for all range of focus. But we have some challenges like understanding of the process, the physical process, the land use, land cover, the issues of interactions between the land, ocean and atmosphere. All that process understanding is a challenge for scientists. Also, in fact, we had a dream that India should have its own model, and instead of we getting from NCAR or any other institution. So this is a regional human component to be added into. All that is going to be a big challenge for us. And the high resolution modeling, for purpose, as I mentioned, the purpose like, you're talking about urban climate model or high resolution nowcasting models and all that, they are going to be seen. So these are the challenges. Resolution, we always have a compromise between resolution and the computing resources available. And now that we are going to have better computing resources, we are already running 12-kilometer model as our for the medium range forecast, that we need of course to introduce a much higher resolution model on the thing. And so at the weather prediction level, 1 kilometer model is the idea that we must have it. IBM already attempting, but that's could be our vision. And even climate model resolution should reach to say 40 kilometer or 50 kilometer level. Impact and decision tools are, in fact, this is the area that we need to work on, how this is going to have and huge computing requirement and numerical modeling. So this is the area that it's slowly diminishing, that we in fact needed a much stronger and much I would say much professional climate modelers, and the younger generation are coming up, and this is the hope that the students in fact are taking interest, and modeling is going to be the expertise that we need to develop. So We have good base, but I think we need to build upon that base here. So, so therefore, the interdisciplinary knowledge of climate and impacted sectors, impact model and decision tool system, and all that leading to reducing. See, ultimate aim is that reducing climate risk and growing climate resilience, because as I said, with higher frequency and intensity of extreme events, we need a very accurate prediction of extreme events. That will help. I compliment Ministry of Sciences yesterday. If you see this severe thunderstorm that came in Delhi, was predicted well in the nowcasting. I mean, maybe people don't read that, don't watch that carefully, but it was predicted. So many people, and that opportunity is given to you. If you believe in forecast, then you are given an opportunity to reschedule your travel or the thing. Somebody doesn't read, that is a different thing, but I think there is a potential for this. So high resolution modeling and the combined with good physics, physical understanding, other thing will improve this thing. Now, if you see the entire game is what? See, climate modeling need these kind of interconnection. So first, understanding the monsoon processes, and for that you will improve model and also test the hypothesis. This is the normal, usual way we do the modeling. The interplay of aerosols, ocean and land, that's all put together. So basically it is land, atmosphere, ocean interaction and the process representation in the model that is the ultimate thing. And I mentioned, as I mentioned that, so at the land level, your carbon uptake and emission, carbon cycle, water cycle, hydrology, character, all that gets into the model, and in the modeling side, you have all sort of, as I already mentioned, I don't want to repeat, that we need to go for regional modeling and high resolution modeling. Monsoon continues to be a big challenge, and we are going to tell you that, of course, a monsoon mission of MOES is already on, and a lot of work has been done. We will complement that with DST initiative. We are thinking to set up a center of excellence on monsoon shortly. And so, monsoon precipitation and then all related things, and so tropical, extratropical interaction, land circle, land management, cloud convection, ecophysics. In fact, this is going to be interesting topic now. In fact, this is the the El Nino year, and the general understanding is that it might impact monsoon this year. But I think I was talking to Secretary, he said that no, it's not going to be so, because it's going to be like 97 and it's going to be maybe a normal monsoon because of various reasons. Otherwise, we don't know. The monsoon and so connections are now weakening, and it's not that every El Nino will give you a guide monsoon. And so these understanding of all these processes, we need research on every of these topics, and of course forecast skill and all. So when the modeling will, in fact, we have been working on these GCM for most of our medium range forecasting, and even climate models are being used or forecast for simulating the climate. I think now time has come that we need to introduce ESM at the community level. So ITM is already working on ESM, but we need an India-centric community model on ESM, and that can be developed by a group of scientists. It can be centered on in an institution, and ITM will help. So it's really a combined effort of MOES and DST to develop, where you have physical climate processes, carbon cycle, nitrogen cycle, human activities, all included as part of the thing, aerosol, agriculture, emission, everything. Now, these are the two, I would say, opposing kind of the influence that you see. If you look at the emission, the mitigation of gases like carbon dioxide, nitrous oxide, the methane and all, that is we do these mitigation action to reduce these gases concentration in the atmosphere, and that will create a carbon a climate benefit. That is, you get those benefits because of these reducing these gases. But if you look at when you are dealing with the air quality or the aerosol, there you will focus on improving the air quality, but actually that will give you climate penalty, because there are two opposing kind of the impact is there. So there reducing the nitrate, reducing the sulfate, reducing the organic carbon, all that will lead to an increase in the CO2, increase in the warming. That is the two different kinds. Therefore, how do we create a balance between the atmospheric component with the air quality component? This is the challenge that we are going to have. So, aerosol climate interactions are going to be the important research area for the future. So, I think I am not going to detail this. I already said that there is so much of that is so aerosol observation. So, there is, see, already I will say the aerosol is one area where 9 ministries and departments have worked independently. MOES, DST, CSIR, DOS, Agriculture, MOEF, and like that. 12 departments, 9 departments have worked in aerosolology. I think this is the time that this is the idea of this conclave to discuss this thing. Can we have one all India coordinated program on aerosol? Just combine everything, all initiative put together, intramural, extramural, and all kind of thing. That will give you address. So aerosol, the issues have still being very important and not being addressed. So we need that kind of initiative and thing. So observation, monitoring, and research need to be combined, and this all ground based, satellite based, all observation I am talking about. Oceans are going to, in fact, not much emphasis has been given on ocean. I'll just finish this. Ocean has not been given much emphasis on this thing, because here we have issues, big issues coming on sea level rise, extreme events, and all connected to the oceans. So the air-sea interaction, apart from that, the kind of you need a big change in fact, all that is very important. I am not going to elaborate on the thing. Hydrology and cryosphere are very important, and there has been consistent improvement in the evolution of this land surface modeling over the time. And but I think in India-centric model that we propose, we must also include glacier component, water management, and crop calendar, and coupling with groundwater lateral flow. These are the things that are not integrated so far, and that India-centric model must include. And also soil moisture monitoring, a lot of work. Suvimal, I forgot. That IIT Gandhinagar has worked. So there, this need to be kind of, and also merging terrestrial water data with satellite. And I think I can skip this. So extreme events I already mentioned. There are issues of modeling, issues of early warning system, attribution to climate change, and connecting science to building resilience. And urban climate, this is already I mentioned that this is a science that you need to handle separately with very high resolution model, maybe 1 kilometer model, and where all the 3 parts, the climate part, the flooding part, and the air quality part, and of course infrastructure impact need to be covered. We already have in DST this network all the thing. A real challenge will be taking our science to the society. So the gap that we have is huge. As I mentioned, people don't read our advisories properly. So these are real gap is that how we take especially the agro-advisory service to the farmers. Sciences has very deep penetration, but I think you need a different level. Now, this is the one which is going to decide the action that you need to take on ground. And the DST initiated, Professor Ravinath is here. We initiated, with new definition, the detailed vulnerability assessment, and now we are working on risk assessment. That will decide all the action by the state governments, and the district administration. Now this is now it's like the risk is now a combination of the vulnerability, hazard, your exposure, and also the response by the society. These are just, I'll just give these are, so whatever the project and the information that we develop must be taken to different sectors. So agriculture is the most important sector where the weather forecast and the climate forecast or climate project should be taken to them. And then infrastructure resilience area, health is a very important. It's like our work, Dr. I think we had some work done by ICMR level, and we did that was used for the malaria forecast, and so weather and malaria issues that I think Dr. Dhiman is here, so he is. So this is a very important area that need to be taken. So on the thing, water is another very important component of climate services, and a lot of work has already been done, but it is needed. A lot of work is needed on the thing. I would conclude. I say the climate change is going to pose great threat to India, mainly because of increase in temperature beyond its threshold limits, that is 1.5 degrees centigrade and beyond, and multi-fold increase in the extreme event in terms of their frequency, intensity, and duration. India with high population density and poverty will be hugely impacted. In fact, one of the countries that is going to be hugely impacted in the world is India because of high population density and poverty. And we have a very robust climate research support in terms of intramural and extramural, but they need to scale up extramural part so that we are able to penetrate to large number of scientists and institutions. As I mentioned in the morning, we have something like 1,400 institutions and more than 3,500 active researchers in the country, apart from 700 research students. We need to reach out to them. So we need to scale up the funding mechanism, and we need a different format for funding than what we have. So we need all the funding agencies to work together to support strategic areas of weather and climate research. It cannot be a general, as I said, you need a different format for research support. And so the National Climate Research Agenda, in that today and tomorrow what we are going to discuss, it must be put into action for implementation by these agencies after, in next few months. That is the idea of this climate research. This is, as I said, this is not a report. It is an agenda prepared by all of us. And I'm so glad today we have the best reigning climate sitting here across the institution, and we try to cover all the three parts, that is academia, research institution, as well as the government institutions. Try to bring everybody together, and also we try to bring researcher and policymakers together, so that the policymakers have appreciation for the research that is being done. And I personally feel very honored to be part of this, and I am honored that I am could help bringing this agenda to this level. So thank you very much, and thank you very much, sir, for giving this.
Thank you, Dr. Gupta. Now, may I request our session chair, Honorable Secretary Dr. M. Ravichandran. Sir, with your permission, may we skip the question answer, because anyway we will be discussing in the parallel sessions because of time bound. So with your permission, can we forward? Okay, thank you, sir. So today we are very happy to inform you that we have received 250 plus registration for this conclave, precisely 256 registrations. So that's a huge response from our climate community. Thank you, everyone. And before we move on to our next parallel sessions, so we will be having a group photographs with all our dignitaries and delegates. Sir, please.